Right. So for today, we are going to deal with statically indeterminate analysis and stresses induced by temperature change, right? So these are still under axial loading configuration. So let's start with an example regarding a shaft. Okay, so we're going to do a shaft. Example number 1. So we are going to do a shaft. So we are going to do a structure. So this structure, one end of the structure will be built in. Okay, so one end of the structure will be built in. So this is built in. And then the structure will look like this. Okay, so this is one of the structure, one part of the structure. And then we have an extension of the structure. So now for this structure now, so this is an example that we're going to work on. So we have location that we declare that this is point A. Over here in between is point B, point C, and then we have point D. And then with all these points, we have a specific dimension. Okay, so we have specific dimension. So one, we take a break from here, over here, and over here. So all these we have a specific dimension. So we have this at, okay, so we have specific dimension. I'll write down the dimension later on. So this is 12 inch, 12 inch, and then the other side you have 16 inch. And then we over here from A to C, the area is equal to 0.9 inches. Okay, and over here is the area is equal to 0.3 inches. So this is not a statically indeterminate structure. Okay, not yet. It's not a statically indeterminate structure yet. So we want to find, so what we want to find is, we want to find the total elongation. Okay, so we would like to find the total deflection Okay, find the total deflection induced by the applied load. Okay, so that's what we're trying. So over here we will have, so the applied load is as follow. So at point B, right, we have a load going in that direction. So that's 75 times 10 to the power 3 pounds. And then at point C, you have a load coming back at you. Okay, that's going to be 45 times 10. Okay, this is no good. So it's going to be 45 times 10 to the power 3 pounds. And then you have one more acting at the end. This is running at 30 times 10 to the power 3 pounds. Okay. So based on all those loads, we're going to find the total deflection. Okay. So I'm going to write out the solution procedure. So the solution procedure is as follows. The solution procedure is as follows. So the first thing that we're going to do, based on what is given to us, so the first thing we're going to do is we're going to divide the rod or divide the structure into components at either A, okay, at either at the load. So we divide based on the load application region, right? So for this case, the load application region, from what we can see, is a 75. The 45 is a 75, 45, and 30 times 10 to the power 3. Okay, pounds. Okay, or okay, at either. So the next one which you divide your component is the change in cross-sectional area. Okay, and C is based on the use of different materials. Okay, the use of different materials. So if you look at our structure over here, if we base on cross-sectional area, right, we only need to section this structure twice. One from A to C, the other one from C to D, right? If we were to divide it based on applied load, okay, it will be from A to B. So based on applied load, you're going to do based on applied load, it will be A to B, you have 1, B to C, you have 2, C to D, you have what? 3. Okay, based on applied load, right? So that's how you divide. So based on area, right? Based on area, you need to divide by what? 2. But based on applied load, you have to divide by 3. So you divide the structure based on the maximum number of section. Okay, for this case, the maximum number is 3. Okay. Any questions so far? We okay?
Why do you want the maximum number of sections?
So that later on when we analyze, we can calculate the deflection by summing each different section. Okay. And why that is the case, you will see when the load is applied at different section, sometimes the load can be omitted. Okay, sometimes you cannot omit those load. So let me go further, then you'll see better. Okay. So one question someone asked, is the extension due to temperature? For this case, not checked. So I think the extension is a different material. For this case, the materials are all the same. Before that, someone asked, is there a time limit for the quiz? So the quiz time limit is basically Monday 2359 for both of them. Quiz 1. So down here we are talking about both quizzes, okay? I do apologize. I just see the questions now. Okay.
I think you meant like the time limit on the quiz. Like, are we like confined to like a certain time frame?
No, because the due time is May 20. As long you hand in by May 18, you are good to go.
Oh, so we have a limited time up until that due date.
Yeah.
Okay.
Okay. This quiz is to make sure that you keep on top of your work. Okay. Not to like give you the stress of the term test or the final, okay? Already coronavirus are killing so many people. I don't want to kill you this way, okay? Not worth it. Right, so after that, we're going to apply the free body diagram. On each subsection. To determine the internal forces, and then we are going to apply, okay, we're going to evaluate the total deflection or the deflection based on deflection is equal to PL over AE. Okay, so last week we derived this formula, and from then the notation that we're going to use is, if we have a member over here, a section over here, is going to be tension. So tension is positive, and if it's under compression, is going to be negative. Okay, so that is the notation that we're going to use. Okay, so as you can see before in the earlier diagram over here, right, we divide them into 3 sections, right? So I'm going to copy this whole thing so you can see better when I write. Right, so the first thing that we'll do, we're going to look into section 1. Okay, we're going to look into section 1. Okay, so section 1, usually everyone will understand section 1. Let me emphasize why. So this is your section 1, right? So in your section 1 over here, this is your point A, and then this is your point B, and then you have a load, right? We have a load over here. So this is 75 times 10 to the power 3 pounds. You have a load going towards the left hand side. It's 45 times 10 to the power 3 pounds. And then the last load over here, you have 30 times 10 to the power 3 pounds. Okay. So we are going to use the notation where tensile is going to be positive, compression is going to be negative. Okay. So at point A, we are aware that point A is built in. It's not going to go anywhere, right? So the 75 is going to induce a what? A tensile. Yes or no? It's pulling it away. The 45 is inducing a compression. And the 30 is going to induce tension or tensile. Okay. So from here, section 1, we know that P1, right, will be equal to 75 times 10 to the power 3 minus by 45 times 10 to the power 3 and plus by 30 times 10 to the power 3. So this will add up to be 75 minus 45 plus by 30. So this is 60 times 10 to the power 3 pound of force, and it's going to be positive. Okay, so we write positive 60 times 10, about 3 pounds, and it's going to be tensile. Okay, that's what we know.